Hi students, my name is Manas Khanduja. Okay, and what I'm gonna teach today is this topic called Le-Chatleir Principle. Okay, Le-Chatleir Principle is one of the most important, interesting, and easiest topic of equilibrium. Okay, it is the most important. Okay, it can be applied. It has a practical approach. It is the most interesting. You can apply it real life. You can think of it. Okay, physical chemistry is mostly about numerical, but this is the theoretical part that has a great practical approach. Okay, industries apply this principle to get a better yield of production. Okay, so it is the interesting. Okay, it is interesting topic. It is easy topic, and it is one of the important topics. So IE for this Le-Chatleir's principle. Now, what is it? Now, Le-Chatleir principle is basically applied on reversible reaction. Okay, reversible reactions are those which whose direction can be reversed at any point of the reaction. Okay, now reversible reaction we know, but how do we apply Le-Chatleir principle to it? Now, Le-Chatleir principle tells us where the equilibrium will shift. Okay, see, Le-Chatleir principle is about equilibrium. Okay, interesting, important, and about equilibrium tells us where the equilibrium will shift. When? Just follow the steps. Okay, this is Le-Chatleir's principle. It tells us where will the equilibrium shift if we change the amount of reactants and product. First thing, change the amount of reactants and products. Okay, now let me just give you an example to tell you how can we apply the Le-Chatleir principle. Now, if you have a reactant A that is reacting with a reactant B to give a compound AB. Okay, just bear with me. We will understand Le-Chatleir principle on its first application. Now, if you somehow increase this A, okay, you are increasing one of the reactant A. Now, what will happen? See, each and everything in universe tries to opposes what we provide them. Okay, if you go in physics, you will read in physics that there are many motors that opposes their driving force. In ninth, you study law of inertia, that a body tries to opposes changes in its state of condition. If it's at rest, it will try to stay at rest, and if it's in motion, it will try to stay in motion. Now, what you have done is you have increased the reactant A. You have changed this equilibrium. So what will this do? It will somehow try to the change you have made. So what it will do? It will decrease it. You are increasing it. Okay, you are increasing it. What it will do? It will try to decrease it. And how it can be done? By making the reaction go forward. Now, if the reaction goes forward, what will happen? A will decreasing, forming AB. Okay, the yield will increase. You see, this is Le-Chatleir principle applied when you are changing the reactants. Okay, you have increased it. You have changed the equilibrium. The equilibrium want to undo the changes made by you. So what it does, it counterattacks you. You are increasing it, it will start decreasing it. How it will decrease it? It will start producing AB with the help of A you have increased. Thus, we have get what we want. That's maximum yield. Now, what you did, this is the change in the reactants. Now, what you can do, if you somehow change this AB and B let decreases. Okay, you have decreased AB. Once again, you have changed the equilibrium. You have changed the state of the condition. You have decreased AB. Now, what this system will try to do? Undo the changes made by you. It does not like the changes you are doing to it. So it tries to undo the changes. What it will do? It will try to increase AB. Once again, reaction goes forward. Your changes can be decided, your effect of your changes can be decided by that principle, which is IIE, okay, Le-Chatleir Principle. So Le-Chatleir Principle, when we changing the concentration, can be applied by this. Now, second thing is, if you change the temperature, then how we will apply this Le-Chatleir Principle? So for temperature, you should know that there are two types of reaction. The first is exothermic reaction, and the second will be endothermic. Now, as you can see, exo is something, what does it exit? Heat. Exothermic reaction produces heat, while endothermic absorbs heat. Okay. So basically, the temperature effect using the Le-Chatleir principle will be explained using these two. Now let's take one more example. Okay, let's this time take reactants X and Z. See, we have taken AB, so we can take X and Z. We take X plus Y2, gives us a compound XY2. And this reaction is producing lot of heat, hence this is exothermic. Okay, this is an exothermic reaction. Now, what you did to this, see, first of all, remember, Le-Chatleir principle is applicable to reversible reaction. That means these reaction will always be in equilibrium. This sign has to be perfect. Okay. So now coming to this reaction, a formation of X5. Now what you do is you increase this temperature. For this reaction, you are increasing the temperature. Now what will be the effect on equilibrium? See, this reaction is already producing heat. Okay, this reaction is producing a lot of heat. And what you are doing to it? You are increasing its temperature. Is it favorable for something? It's like there's fire on your house and you are adding something that will increase the fire. So will it increase the heat? No. So whenever there is exothermic reaction, increasing temperature takes the reaction or takes the equilibrium backwards. Okay. Whenever the reaction is exothermic, increasing temperature will decrease the yield of the reactants. Okay, the yield can be increased by decreasing temperature. Okay, so already heat is producing. It's like adding petrol to a burning factory. Okay, so try to decrease the temperature whenever there is exothermic if you want the reaction to be moving forward. No one wants to move backward in their life. Okay, if we have an agency for ammonia, like we can take a better example. We all know this Haber's process. This is N2 plus S2 and that give us NH3. Okay. And like in 9th, 10th, everyone know how to balance this reaction, that 1 mole of N2 will react with 3 mole of ammonia to, 3 mole of hydrogen to give 2 moles of ammonia. Now, this reaction is exothermic. Okay. Our class 9th, 10th book have basically tell us that it has minus 93 kilojoule exothermic heat that we have marked up. Okay, so this is an exothermic reaction. Now, if you increase this temperature, you are the owner of this factory which is producing ammonia, and you increase this temperature. Okay, you said increase the temperature of production. It's usually 500 degrees Celsius temperature, and if you increase the temperature, if you increase ahead this temperature, then since it's an exothermic reaction, it will try to move in backward. Okay, exothermic reaction on increasing the temperature moves in reverse direction. Okay, but this reaction is one of the rare examples where increasing temperature helps the reaction. See, chemistry is full of exception, and that's why I write this reaction. See, Le-Chatleir principle can be applied anywhere. This rule is applicable for each and everything, that exothermic reaction are always move in backward direction when increasing the temperature. But this reaction, that is Haber's process, is done at a very high temperature such that rate of reaction is not very low. Okay. See, basically, I just told that Le-Chatleir principle. Whenever faces an exothermic reaction, it can be applied that if you increase the temperature, the reaction will go backward, and if you decrease the temperature, the reaction will go forward. But I actually write this reaction so that you remember this exception, that whenever you are forming ammonia, your mind will say this reaction is always equilibrium. It is the biggest example that you face for Le-Chatleir principle. Okay. But you always remember that this reaction takes place at high temperature, not because of the Le-Chatleir principle failure, but because of high activation energy of this reaction. Okay, activation energy is very high for this reaction, and therefore it is required to be done at a very high temperature. Okay, so Le-Chatleir principle basically tells us that what will happen to the system whenever we changes the condition. Okay, I have talked about concentration of reactant, I've talked about concentration of product, I even talk about temperature. See, if I have told you about exothermic, you can tell about endothermic. Any endothermic reaction will be supported or will move in forward direction if you increase the temperature. That's obviously when exo and endo are opposite, their temperature effect will also be opposite. Temperature increase forward direction for endothermic. Okay, while for exo, this will lead to a backward direction movement in reaction. See, movement in backward direction is like, I will give you a better example that, okay, we take this example of methane oxidation. CH4 plus O2, and we produce CO2 plus H2. Okay, so going in backward direction means that even though we wanted to produce CO2, the reaction will be producing methane. That means going in backward direction. Okay, forward direction is as required by it. Methane on oxidation will give CO2. But if it is going backward, that methane is being produced, that is actually named by going in backward direction. So see, Le-Chatleir principle is just anything. I try to do a change in you, you will try to undo the change done by me. I will give you one or more example that you can apply on yourself. Now think of a class where you have been applied with lots of pressure. Okay, there is a class. This third topic is talk about the change in pressure. Okay, the pressure, what will Le-Chatleir principle, how Le-Chatleir principle will help us to decide the movement of equilibrium shift. So we are changing the pressure. Now think of this. You are a class student, and let me just say that this is this reaction A2 gas plus 2B2 gas gives you AB2, and we can just balance this reaction by this. Okay, this is the reaction. Now, if this is an equilibrium also. Okay, this reaction is an equilibrium. So what I do, if I increase this pressure, if I increase the pressure for this reaction, now where will the equilibrium shift? Now think of it as yourself. You are in a class. You have been facing a lot of pressure. Will you stay there or move to a class with less number of people? See, people in reaction are decided by number of gaseous moles. Okay, number of gaseous moles are people here. Now here number of people on the reactant sides. See, this is 1 mole and this is 2 mole. 3 mole on the reactant side while 2 moles on the product side. You are compressed in a place. Where will you go where there are less number of people? If there is a room, okay, if there is a room and there is this big room, and here you are 5, 6, 3, 4, while here there is only one boy. So if I compress this here, okay, I increase the pressure here, where will these people go? They will go to a place where there are less number of people. And I said that we refer people as number of gaseous moles. So whenever you increase the pressure of a reaction that is in equilibrium, the equilibrium moves in the direction of less number of gaseous gaseous moves. Okay, increasing pressure. If we increase pressure, the equilibrium moves in the direction of less number of gaseous moves. So we talk about change in concentration and change in concentration of reactant. That if you increase the concentration of reactant, the equilibrium will try to decrease it, so reaction goes forward. Second, we talk about temperature that was divided into two, exo and endo. Exo, temperature increase, it is not very much useful for it. It will try to move the reaction backward. Endo, want some heat, you give increase in temperature to it. It already needed that. It will thank you by moving in the forward direction. Now, when we talk about the third condition, that change in pressure, you are changing the pressure, so that depends upon gaseous mode. Here the gaseous modes were 3. Here the gaseous modes are 2. If you are increasing the pressure on people, they will move at an empty space. Now, see, there are 4 people and they are already compressed. And you try some more pressure is put on them. So they will move to an empty space. Now, they will try to go in a room that is large, that has less number of people. So that's why they choose this 2-number gaseous mode. So whenever we increase the pressure, then Le-Chatleir principle states that equilibrium moves in the direction of less number of gaseous mode. So Le-Chatleir principle basically tells us the changes in equilibrium whenever we change the system states. Like if we change its pressure, if we change its temperature, if we add something, or if we try to remove something. Okay, so Le-Chatleir principle is very much helpful whenever we talk. It's a practical application in industries. Okay, you are producing H2SO4. If you are producing what we call ammonia and many other acids, bases, and solutions that are required in daily life, the yield is the most important thing. No company wants or no industry will want a slow or less amount of yield. So Le-Chatleir principle has great application in that. And we will find Le-Chatleir principle in different subjects with different name. But you could relate that it is something similar that we studied under equilibrium, the law which tells us how the system will perform whenever we try to change its states. Okay, so that's me, Manas Khanduja, and this was the most IIE interesting, important, and easiest topic of equilibrium. So thank you.